Through the field glasses that morning of February 19th, 1945, Captain Masao Hayauchi witnessed something that made no sense according to every manual, every lecture, every lesson from the Imperial Military Academy. Vehicles were materializing from the Pacific Ocean itself, emerging from the waves and driving straight up the volcanic beaches of Iwo Jima, as though the fundamental barrier between water and land had simply ceased to exist. His hands shook slightly as he tracked their movement from the concealed bunker position overlooking Red Beach 2. These machines should have been sinking, Hayauchi kept thinking. The laws of amphibious assault were clear and absolute. Landing craft deposited their cargo at the water's edge. Troops and supplies transferred to shore vehicles. The beach became a bottleneck, a killing zone where defenders held every advantage. 15 years of service in the Imperial Army, campaigns across China, months spent fortifying Pacific strongholds, all of it had taught him that the waterline was where invasions succeeded or failed. Yet here were six-wheeled trucks simply rolling out of the sea with their cargo beds stacked high with ammunition crates and medical supplies, driving across the black volcanic sand that Japanese engineers had calculated would trap any wheeled vehicle within meters of the surf. What Hayauchi was watching, though he couldn't fully comprehend it yet, represented the deployment of 2,300 DUKWs that would fundamentally rewrite how the Pacific War's bloodiest battles unfolded. These weren't landing craft that halted at the shore. These weren't amphibious tanks built for combat. These were cargo trucks that treated the ocean as just another variety of roadway, erasing the distinction that all defensive planning depended upon. The tactical crisis this created for Japanese defensive doctrine ran deeper than any single battle could illustrate. The entire mathematics of island defense had been predicated on one calculation: how many Marines could storm ashore versus how continuously supplies could reach them. Now those equations were being rewritten by an endless stream of vehicles that flowed without interruption from ship holds directly to frontline positions. Down in the tunnel complexes beneath the island's airfields, Lieutenant Commander Takeo Ishikawa had spent the hours before dawn studying the approaching American fleet through periscope observations. 8 months of preparation had gone into defensive plans built around one inviolable truth: beaches determined victory or defeat in amphibious operations. Everything Ishikawa and his staff had learned from the disasters at Tarawa and Saipan had reinforced this principle. General Tadamichi Kuribayashi had revolutionized Japanese defensive thinking by abandoning the suicidal banzai charges at the waterline. Instead, the defense of Iwo Jima employed depth, artillery concealed in cave systems, interlocking fields of fire, machine gun positions built into reinforced concrete, and volcanic sand itself weaponized to exhaust infantry and immobilize vehicles. The entire concept assumed attacking forces were most vulnerable during that critical transition from sea to land. From his position on Chichijima, Major Yoshitaka Hori had functioned as Kuribayashi's logistics coordinator, spending months calculating what tonnage the Americans would need to sustain an offensive. His analysis, shared in communications with Kuribayashi, showed the Japanese understanding of amphibious limitations. 500 tons daily minimum to maintain attacking momentum. Traditional landing craft might deliver 200 tons under ideal conditions. Beach congestion would cut that in half. Time, weather conditions, and Japanese artillery would do the rest. The DUKWs demolished these calculations completely. Each vehicle could transport 2.5 tons of cargo or 25 combat-loaded troops. They moved at 6 knots through water, 50 miles per hour on roads. Most devastating of all, they required no unloading at the beach, no vulnerable transfer moment, no congestion at the waterline. The American designation DUKW meant nothing when translated into Japanese, just as the vehicles themselves meant nothing could be translated into existing tactical frameworks. At 0930 hours on February 19th, Captain Hayauchi transmitted an urgent message to General Kuribayashi's headquarters. The enemy deploys amphibious vehicles that bypass the beach entirely. They proceed inland with full cargo loads. Our beach obstacles achieve nothing. Artillery cannot track them during sea-to-land transition. Immediate tactical revision required. No revision could compensate for what these vehicles represented, though. They weren't simply machines, but a complete reconceptualization of how amphibious warfare functioned. Japanese forces had invested 2 years perfecting defenses against traditional landing craft, studying the patterns of Higgins boats and LCMs, calculating transfer times, vulnerability windows, beach bottlenecks. Every calculation had just become obsolete. Medical evacuations provided the first shock. Within hours of the initial assault, wounded Marines were being transported straight from battlefield aid stations to hospital ships. No waiting for returning landing craft. No exposure on contested beaches. DUKWs configured as ambulances drove directly to casualty collection points, loaded the wounded, and drove into the ocean. From a concealed position near Airfield No. 1, Lieutenant Toshio Abe of the Japanese Naval Landing Force observed this process. His post-war interrogation revealed the psychological impact. American casualties had been calculated based on evacuation delays. Wounded would accumulate on beaches. Morale would deteriorate. Instead, casualties disappeared into the sea minutes after being hit. The ocean had become their hospital. The ammunition supply system proved even more devastating to Japanese planning. Traditional amphibious operations required ammunition dumps on beaches, vulnerable targets for artillery and counterattack. DUKWs eliminated this weakness entirely. They drove from supply ships straight to artillery positions, delivering shells within yards of the guns. No dumps, no static targets, continuous flow. Colonel Takechi Nishi, the former Olympic equestrian now commanding tank units, reported to Kuribayashi on February 21st from positions near the eastern beaches. American artillery never runs short of ammunition. Our counter-battery fire hits empty sand. Their supplies flow like water, finding its level, impossible to interdict. The ability of DUKWs to adapt to conditions kept proving equally shocking. When volcanic ash clogged air filters on conventional vehicles, DUKW crews simply drove into the ocean to wash them clean. When Japanese artillery zeroed in on beach unloading areas, DUKWs dispersed across miles of coastline, entering and exiting water at unpredictable points. When rough seas threatened traditional landing craft, DUKWs rode the waves, their boat-shaped hulls handling conditions that would have halted conventional operations completely. Sergeant Yoshio Yamada of the 145th Infantry Regiment, among the handful of Japanese who survived the battle, later described watching DUKWs operate during a brief fighting lull on February 24th. They moved like amphibious ants in endless columns from sea to shore to battlefield and back. Destroying 1, 2, even 10 achieved nothing. Dozens more continued the flow. They had transformed the ocean into a highway and reduced our island to just another destination along their route. The origin story of these vehicles was as remarkable as their battlefield impact. In 1942, a yacht designer named Rod Stevens, a British sailor named Dennis Puliston, and an MIT engineer named Frank Spear had proposed mounting watertight hull construction onto standard GMC truck chassis. Military authorities initially rejected the concept as impractical. Only after a Coast Guard patrol boat ran aground off Provincetown and an experimental DUKW rescued the crew in conditions that defeated conventional craft did the military recognize the vehicle's potential. Development took just 38 days, a speed of innovation that Japanese military bureaucracy could never have matched. General Motors would eventually manufacture 21,147 DUKWs. Each required 18,000 separate components assembled in factories across America. The engine, a GMC Model 270 producing 91 horsepower, was identical to what standard military trucks used, ensuring spare parts and maintenance expertise existed everywhere American forces operated. Japan had actually attempted developing similar amphibious vehicles. The Type 2 Suzuki, manufactured by Toyota, was designed for comparable roles. But Japan managed producing only 198 units between 1943 and 1944, most lost when American submarines sank their transport ships. The Suzuki's 2-ton capacity fell short of DUKW capabilities, and its complexity made field repairs nearly impossible. Captain Hiroshi Kuwahara, a technical officer involved in the Suzuki project, was captured on Saipan and later interviewed about Japanese amphibious vehicle development. We understood the concept but lacked industrial capacity. Each Suzuki required precision parts we could barely manufacture in peacetime. The Americans built thousands while fighting globally. This wasn't a technological gap, but a fundamental difference in industrial philosophy. DUKW impact extended beyond logistics to reshape Pacific battles entirely. On Saipan in June 1944, their appearance had already begun unraveling Japanese defensive planning. Lieutenant General Yoshitsugu Saito had positioned his 32,000 troops based on traditional amphibious assault patterns. Beach defenses created a killing zone during the critical unloading phase. Colonel Takuji Suzuki, Saito's chief of staff, had spent weeks calculating the time Americans would need establishing supply dumps, the vulnerability of those dumps to artillery fire, and the inevitable logistics crisis that would slow their advance. The first DUKWs arrived at Saipan beaches at 0852 on June 15, 1944. Within 4 hours, they had delivered more ammunition to marine artillery positions than Japanese planners estimated could be landed in 2 days. The continuous supply flow enabled American forces to maintain pressure without the operational pauses Japanese defense required for reorganization and counterattack. Major Kiyoshi Yoshida, intelligence officer for the 43rd Division on Saipan, wrote in a report never sent due to his death in the final Banzai charge. The enemy's amphibious trucks render our calculations meaningless. We prepared for an enemy that must pause building supply dumps. Instead, they advance with their logistics like a river carrying its own banks. The 476th Amphibian Truck Company, an African-American unit operating DUKWs at Iwo Jima, exemplified how these vehicles transformed amphibious operations. On February 19, 1945, they began operations under intense Japanese fire. Their DUKWs were specially modified, carrying 105mm howitzers, weapons that traditionally required extensive beach preparation before landing. The howitzers were firing from inland positions within hours of initial landing, something Japanese defensive doctrine deemed impossible. Technical Sergeant William McBride of the 476th later recalled the Japanese reaction. You could see their confusion. Artillery appearing where no artillery should exist. Supplies flowing where no roads existed. We weren't just invading, we were rewriting the rules. The psychological impact on Japanese defenders matched the practical effect. These vehicles represented something beyond military capability. They embodied an industrial philosophy rendering Japanese defensive doctrine obsolete. Every DUKW demonstrated American mass production, standardization, mechanical reliability. They weren't specialized military equipment, but militarized commercial vehicles, suggesting an economy that could convert civilian production to military use without strain. Lieutenant Tadashi Komatsu, an engineer officer who survived the battle for Guam, was interrogated about Japanese defensive preparations. He revealed profound demoralization among technical officers who understood what DUKWS represented. When we saw the amphibious trucks, we knew we faced not just an army, but an entire industrial system. Each vehicle proved America could transform any mechanical concept into thousands of functioning machines. DUKW maintenance and repair provided another shock to Japanese observers. Unlike complex military equipment requiring specialized parts and expertise, DUKWS used standard GMC truck components. A damaged engine could be replaced with one from a regular truck. Tires were interchangeable with thousands of other vehicles. The propeller shaft was a modified truck drive shaft. This standardization meant DUKWs damaged by Japanese fire often returned to service within hours. Commander Mitsuo Fuchida, who had led the Pearl Harbor attack and was now serving as staff officer in Japan, received reports about American amphibious operations. He later wrote in memoirs that Americans had achieved what the Japanese never understood was possible: the democratization of amphibious warfare. Any mechanic could repair their amphibious vehicles. Any soldier could operate them. They had removed the specialization that Japanese forces believed amphibious operations required. Production statistics told a story Japanese industrial planners could barely comprehend. The Pontiac East Assembly Plant in Michigan initially produced DUKWs alongside regular trucks, converting existing production lines rather than building new facilities. Workers building commercial trucks on Friday were building amphibious vehicles by Monday. Conversion required no new training, no special tools, no fundamental assembly process changes. By contrast, each Japanese Suki required specially trained workers using precision tools in dedicated facilities. The St. Louis plant alone produced 300 DUKWs monthly by 1944. Colonel Masahide Ando, who oversaw military production in Japan, learned about American DUKW production while a prisoner after the war. He recorded his reaction in prison diary entries. They built amphibious vehicles the way we built bicycles, as though complexity meant nothing. Each month they produced more DUKWs than we produced trucks of all types. The central tire inflation system on DUKWs particularly amazed Japanese technical officers. Drivers could adjust tire pressure while moving, reducing pressure for soft sand, increasing it for roads. This technology, which Japan hadn't even contemplated, was standard equipment on every DUKW. It represented not advanced engineering, but thoughtful design, applying existing technology to solve practical problems. Major Kenji Hatano, captured on Okinawa, had been responsible for vehicle procurement for the 32nd Army. During interrogation, he repeatedly returned to this feature: adjustable tire pressure while driving. We couldn't produce reliable tire valves for standard pressure. They had mastered variable pressure as routine equipment. Each detail showed the gap wasn't in knowledge, but in industrial capability. Beach conditions at Iwo Jima had been carefully chosen by Japanese planners to defeat wheeled vehicles. The volcanic sand mixed with ash from Mount Suribachi created a surface conventional trucks couldn't navigate. Japanese engineers had tested captured American vehicles on similar terrain, confirming wheeled transport would bog down within meters of the waterline. The defensive plan depended on this natural obstacle. General Kuribayashi himself had walked the beaches, feeling the sand between his fingers, confident it would trap American vehicles. DUKWs defeated the volcanic sand through design features the Japanese hadn't anticipated. 6-wheel drive provided traction where 2 or 4 wheels would have failed. The central tire inflation system allowed drivers reducing pressure until tires became improvised tracks. The vehicle's weight distribution, designed for flotation, also prevented sinking into soft surfaces. Corporal Hideo Takayama, an artillery observer who survived hiding in cave systems, watched DUKWs operate on terrain stopping Japanese vehicles. They drove through volcanic ash that swallowed our trucks to the axles. When they got stuck, they deflated tires and crawled out like tracked vehicles. Upon reaching solid ground, they reinflated and continued at full speed, like watching vehicles transform themselves, matching the terrain. Supply figures achieved by DUKWs at Iwo Jima defied Japanese logistics doctrine. On February 24th alone, DUKWs delivered 8,000 tons of supplies from ship to shore, exceeding what the entire Japanese garrison had consumed the previous month. This included 100,000 gallons of water, critical on an island where fresh water was nearly non-existent. Traditional landing craft could never have maintained such volume under fire. Japanese planners had calculated water shortage alone would weaken American forces within days. Instead, DUKWs created a pipeline of fresh water from ship to shore. Lieutenant Commander Saburo Hayashi, intelligence officer for the Naval Guard Force on Iwo Jima, calculated supply rates from a concealed observation post before being killed on February 27th. His notes, recovered from his body, showed increasing desperation. Enemy supply rate 300 tons per hour. Our disruption effect negligible. Ammunition expenditure stopping one vehicle 40 to 50 rounds. Vehicles available appears unlimited. Tactical recommendation, no solution within current capabilities. DUKWs also transformed American casualty rates by enabling rapid evacuation. Traditional amphibious assaults saw wounded accumulating on beaches waiting for landing craft to return. Many died from treatment delays. The Japanese had factored these delays into defensive calculations, knowing mounting casualties on beaches would demoralize attacking forces. DUKWs converted to ambulances could evacuate wounded within minutes of injury. They drove directly from aid stations to hospital ships, maintaining stability, preventing further injury during transport. Vehicles were equipped with stretcher racks, plasma bottles, even surgical equipment. Medics could begin treatment while the DUKW was still moving. DUKWs proved particularly demoralizing to Japanese defenders who had counted on darkness for reorganization and resupply. DUKWs equipped with infrared lights invisible to Japanese forces continued operations 24 hours daily. Supplies flowed ashore continuously. Wounded were evacuated in darkness. Artillery received ammunition for pre-dawn bombardments. The Japanese, who had always used night as their ally for infiltration and surprise attacks, found darkness no longer provided sanctuary. Captain Yoshimasa Wada, defending approaches to Airfield No. 2 on Iwo Jima, reported to General Kuribayashi on February 25th. The enemy maintains full logistics operations in complete darkness. Our night counterattacks find their positions fully supplied with ammunition. They fight a continuous battle while we fight a series of daily battles. Time itself has become their weapon. Repair and maintenance infrastructure for DUKWs demonstrated American organizational capability stunning Japanese officers. Mobile repair units accompanied DUKW battalions, carrying spare parts and tools. Damaged vehicles were repaired on beaches or towed to repair areas by other DUKWs. Parts interchangeability meant several damaged vehicles could be cannibalized, creating one functioning unit. This contrasted sharply with Japanese equipment, where each damaged vehicle was total loss. Major Ichiro Yamaguchi, a logistics officer who had studied at the German War College before the war, understood the implications. He wrote in his diary before dying in the final Iwo Jima assault, "Each broken vehicle becomes parts for others. Nothing is wasted. They practice industrial warfare while we practice spiritual warfare. The outcome is predetermined." DUKW fuel systems revealed another level of American logistics superiority. Each vehicle carried 40 gallons of gasoline, providing a range of 230 miles on land and 50 miles in water. More impressive was the refueling system. DUKWs could be refueled while afloat from naval vessels or while driving from fuel trucks. No stopping, no vulnerability, continuous operation. The Japanese, struggling with fuel shortages throughout the war, watched Americans burn gasoline with abandon. Lieutenant Jiro Suzuki observed DUKW refueling operations from a concealed cave on Saipan. They refueled while swimming, pumping gasoline from ship to truck as though the ocean was a filling station. Upon reaching shore, they refueled while driving, one vehicle pumping fuel to another without stopping. They had eliminated every pause, every vulnerability we had studied. The versatility of DUKW missions exceeded anything in Japanese military doctrine. Within a single hour on Iwo Jima, the same vehicle might transport wounded to ships, return with ammunition, deliver water to frontline positions, evacuate prisoners, and finally transport replacement troops to combat zones. This flexibility made it impossible for Japanese forces to predict or interdict DUKW movements. They had no pattern, no specialization that could be exploited. Colonel Toshinari Shoji, operations officer for the 109th Division, attempted developing tactics against DUKWs. His report, never completed due to his death, contained fragments of frustration. The vehicles have no pattern. They are ambulances, then supply trucks, then troop carriers, then artillery transporters. To defend against one role leaves vulnerability to others. They are not vehicles, but a system we cannot match. Communication equipment on DUKWS added another dimension to effectiveness. Each vehicle had radio equipment allowing coordination with naval vessels, ground forces, and other DUKWS. This created a logistics network responding instantly to changing battlefield requirements. When Marines needed ammunition, DUKWs were already loading it aboard ships. When artillery needed shells, DUKWS were already en route. The Japanese, relying on runners and field telephones constantly cut by bombardment, couldn't match this coordination. Sergeant Major Kaisuke Mori, one of the highest-ranking Japanese NCOs surviving Iwo Jima, described the effect during post-war interrogation. Their supply system anticipated needs. Ammunition arrived before requests. Water appeared before thirst, as though they could see the future of the battle. The impact on Japanese morale was catastrophic. Soldiers who had trained months defending beaches watched those beaches become highways. Officers who had studied amphibious warfare at staff colleges saw their education rendered obsolete. The appearance of DUKWS was often the moment Japanese defenders realized the war was truly lost. They had prepared for an enemy that would struggle at the waterline. Instead, they faced an enemy making the waterline irrelevant. Private First Class Shoichi Matsumoto, who surrendered on Guam after holding out in caves for months, explained his despair. When I saw trucks driving from ocean to land without stopping, I knew we faced something beyond military defeat. We faced a civilization that could transform nature itself into a tool of war. The American production philosophy behind DUKWS represented something incomprehensible to Japanese military culture. These vehicles weren't carefully crafted weapons, but mass-produced tools, built assuming quantity mattered more than perfection. They were designed to be expendable, used and replaced, contradicting everything in Japanese military tradition about equipment value. Each Japanese aircraft, tank or vessel was built with meticulous care, treated as precious, irreplaceable. The Americans built DUKWs expecting them to be destroyed, knowing 10 more were already rolling off assembly lines. Lieutenant Colonel Hideki Yamane, a staff officer captured on Okinawa, struggled explaining this to fellow prisoners. They built vehicles expecting them to be destroyed. Each loss meant nothing because 10 more were already built. We built vehicles as though each was irreplaceable. This philosophical difference was a difference in civilization. By March 1945, over 2,000 DUKWs were operating across the Pacific Theater. They had delivered millions of tons of supplies, evacuated tens of thousands of wounded, and transformed amphibious warfare from specialized operation into routine logistics function. The Japanese had no response because the problem wasn't tactical but systemic. They faced an enemy that had industrialized warfare itself. DUKWs weren't just vehicles, but manifestations of an entire civilization's approach to problem-solving. Admiral Soemu Toyoda, Commander-in-Chief of the Combined Fleet, received reports about DUKW operations throughout 1944 and 1945. In post-war memoirs, he wrote a telling passage. The American amphibious trucks were not their victory. They were proof of their victory. Any nation that could conceive, design, build and deploy thousands of such vehicles while fighting globally had already won. We were merely acting out the final scenes of a concluded drama. The technical specifications of DUKWs that so impressed Japanese observers were actually modest by American standards. The vehicle weighed 13,000 pounds empty, 20,000 pounds loaded. Its maximum speed of 50 miles per hour on land and 6 knots in water was unremarkable. Innovation lay not in revolutionary technology, but in integration of existing systems into new configuration. This itself was a philosophy foreign to Japanese military thinking, which separated naval and land equipment absolutely. A truck was a truck, a boat was a boat. The categories were inviolable. Captain Yukio Nakamura, a naval architect who had designed landing craft for the Imperial Navy, learned about DUKWs while a prisoner. His reaction revealed the conceptual gulf between the two militaries. We never considered a truck could be a boat or a boat could be a truck. The categories were absolute. The Americans ignored categories and solved problems. This is why we lost. Not in battle, but in imagination. The logistics trail created by DUKWs extended far beyond beaches. These vehicles supplied advanced units traditional logistics could never have reached. They crossed coral reefs that would have torn conventional landing craft apart. They navigated jungle streams delivering supplies miles inland. They climbed grades, defeating tracked vehicles. Each capability multiplied their effect, creating supply lines where Japanese planners assumed none could exist. The Japanese had chosen defensive positions based on distance from beaches, believing American supply lines would stretch and break. DUKWs made distance irrelevant. Major Toshiro Abe, defending the Orote Peninsula on Guam, reported the impossible logistics situations DUKWs created. Enemy units appear supplied in locations our trucks cannot reach. They establish artillery positions where we calculated no ammunition could arrive. They fight where fighting should be impossible because supply should be impossible. Training of DUKW operators represented another shock to Japanese military observers. American drivers received only 3 weeks instruction before deployment. Vehicles were designed so simple that any truck driver could quickly learn operation. This contrasted with Japanese special naval landing forces requiring months of training for amphibious operations. The democratization of specialized warfare capabilities seemed impossible to Japanese military culture, where specialization was everything. Ensign Hiroshi Tanaka, captured after the naval battle of the Philippine Sea, observed DUKW operations while a prisoner on Guam. Teenage soldiers operated these complex machines as though driving farm trucks. No special units, no elite training, just ordinary Americans performing extraordinary operations. We had made warfare professional. They had made it industrial. The maintenance schedule of DUKWs would have seemed fantasy to Japanese logistics officers. Vehicles required basic maintenance every 1,000 miles or 50 operating hours. Major overhauls were needed only after 6,000 miles. In contrast, Japanese vehicles in the tropical Pacific required constant maintenance, with major components failing regularly in heat, humidity, and salt air. The reliability came from over-engineering and quality materials Japan couldn't match. Every component was built stronger than necessary, designed for conditions worse than reality. Technical Sergeant Masato Ogawa, a motor transport specialist captured on Luzon, examined captured DUKWs and was astounded by their construction. Every component was stronger than necessary. Bolts that could hold 1 ton were used where pounds of pressure existed. They built for conditions worse than any reality. We built for minimum requirements, and reality always exceeded them. The supply chain supporting DUKW operations stretched back to factories in Detroit, St. Louis, and Pontiac. Ships carried spare parts across the Pacific in quantities defying Japanese comprehension. An entire DUKW could be reconstructed from spare parts available in field depots. Engines, transmissions, hulls, propellers, all were available thousands of miles from factories. This depth of supply meant mechanical failure never stopped operations, only briefly delayed them. The Japanese, who often waited months for critical parts, couldn't comprehend such abundance. Colonel Shigeharu Asaida, intelligence chief for Imperial General Headquarters, analyzed American logistics capabilities from captured documents. Each amphibious truck was supported by 10 tons of spare parts. They prepared for every vehicle to be rebuilt twice. We couldn't provide basic parts for the vehicles we had. They planned repairing vehicles that didn't yet need repair. Combat modifications of DUKWs showed American adaptability. Japanese forces couldn't match. Some were equipped with rocket launchers, turning supply vehicles into mobile artillery. Others mounted 50-caliber machine guns for beach suppression. Some carried smoke generators screening landing operations. The basic vehicle became a platform for endless modifications, each adapted to specific battle conditions. The Japanese, with rigid military doctrine, couldn't conceive such flexibility. Lieutenant Kenji Ogata watched modified DUKWs operate during the Okinawa invasion. One moment bringing supplies, the next firing rockets, then laying smoke screens. The same vehicle performed every role. We had specialized equipment for each task. They had one vehicle doing everything. Fuel consumption of DUKWs, roughly 8 miles per gallon on land and 3 miles per gallon in water, would have been prohibitive for Japanese forces struggling with fuel shortages since 1942. But American logistics treated fuel as unlimited. DUKWs consumed thousands of gallons daily at each invasion beach, supplied by naval tankers themselves, burning thousands more gallons reaching combat zones. The profligacy of fuel use demonstrated resources beyond Japanese imagination. Commander Tetsuo Yamamoto, a logistics specialist for the combined fleet, calculated American fuel consumption from intelligence reports. Each amphibious truck burns more fuel in a day than a Japanese infantry company receives in a month. They burn fuel as we burn incense, continuously and without thought of conservation. Weather resistance of DUKWs proved crucial in Pacific operations, where tropical storms and monsoons regularly interrupted traditional logistics. Vehicles operated in conditions stopping conventional landing craft. Their sealed hulls and high freeboard allowed operation in seas that would have swamped Higgins boats. The propeller and rudder, protected by hull design, survived impacts with coral and debris disabling conventional vessels. During a typhoon striking Okinawa in October 1945, DUKWs continued evacuation operations while all other landing craft were withdrawn. Captain Masami Sato, witnessing this from captivity, wrote to his wife in a letter never sent, "The Americans fight nature itself and win. Their trucks swim through typhoons. What chance did we ever have?" Navigation equipment on DUKWs included compasses, depth finders, and radio direction finders, allowing operation in zero visibility. Fog, smoke, and darkness didn't stop logistics flow. This 24-hour capability meant American forces could sustain continuous operations, while Japanese forces, dependent on daylight for supply, weakened during night battles. The temporal advantage was as decisive as the material one. Major Yoshiki Tanaka, defending northern Iwo Jima, reported the continuous pressure enabled by DUKW logistics. They attack at dawn with full ammunition from night supply. They attack at noon with fresh troops delivered that morning. They attack at dusk with supplies arriving as they fight. We defend the same positions with the same diminishing resources. Time is their ally and our enemy. The simplicity of DUKW operation meant damaged vehicles could be operated by wounded crew. Controls were straightforward: a standard truck transmission, a transfer case lever for the propeller, and a bilge pump switch. Wounded drivers could continue missions. Wounded crew could still unload cargo. This redundancy in human systems matched redundancy in mechanical systems. Everything was designed to continue functioning despite damage. Corporal Takeshi Yamada observed wounded Americans operating DUKWs on Saipan. The driver's arm was bandaged, blood seeping through. He drove one-handed from ship to shore to hospital and back. In our army, he would be evacuated. In theirs, he continued the mission. Their wounded were more capable than our healthy. The psychological warfare aspect of DUKWS was unintentional but devastating. Japanese soldiers had been told they were racially superior, that American soldiers were soft, dependent on comfort and technology. DUKWS confirmed the technology but contradicted the softness. Americans who could produce such vehicles were not weak but incomprehensibly strong. The cognitive dissonance destroyed morale more effectively than propaganda ever could. Private Nobuo Suzuki, one of only 216 Japanese taken prisoner on Iwo Jima, explained his surrender. "When I saw trucks driving from ocean to land, I knew everything I'd been told was wrong. If they could do the impossible with vehicles, what else had I been told that was false?" Production rate of DUKWS accelerated throughout the war. From 100 units monthly in 1942 to over 1,000 monthly by 1945. Each increase in production corresponded to expansion of Pacific operations. The Japanese, monitoring American industrial output through intelligence sources, watched the numbers with growing despair. They could calculate their own defeat in DUKW production statistics. Colonel Hiroshi Takahashi, intelligence staff at Imperial General Headquarters, tracked American production through intercepts and neutral country reports. His final report, written days before Japan's surrender, contained a telling line. "Each month they build more amphibious trucks than we build vehicles of all types." The war is not island to island, but factory to factory, and in that war we were defeated before Pearl Harbor. The civilian origins of DUKW technology particularly disturbed Japanese military thinkers. The vehicle was designed by yacht designers and civilian engineers, not military specialists. It was built in factories that had produced commercial trucks, not weapons. This suggested American civilian industry could be converted to military production without specialized knowledge or equipment. The entire American economy was a potential weapons factory. Lieutenant General Shuichi Miyazaki, Chief of Staff of the Japanese Army in the Philippines, understood implications when he learned about DUKW origins. If yacht builders could design military vehicles defeating our defences, what could their actual military engineers produce? We faced not an army, but a nation in arms, where every citizen was a potential weapons designer. Standardization across DUKW units meant vehicles from different manufacturers, built months apart, remained completely interchangeable. Parts from a Pontiac-built DUKW fit perfectly in a St. Louis-built vehicle. This standardization, achieved across multiple factories and thousands of workers, represented industrial coordination Japan had never achieved even in peacetime. Major Akira Yamada, a production engineer before the war, learned about American standardization while a prisoner. He wrote in his diary about the impossibility of matching such precision at scale. They achieved tolerances we couldn't maintain in a single factory across an entire nation at war. Every bolt was identical. Every gear was interchangeable. This wasn't production, but a philosophy of production we never imagined. Disposal of damaged DUKWS showed American material abundance. Japanese forces couldn't comprehend. Vehicles damaged beyond economical repair were simply pushed into the ocean or buried. No attempt at salvage. No effort to recover precious materials. The waste was strategic, demonstrating unlimited resources. New vehicles were already en route, replacing any losses. Captain Yutaka Tanaka watched Americans dispose of damaged DUKWs on Okinawa. They pushed into the sea trucks we would have spent weeks repairing. Metal we would have melted and recast was abandoned. They could waste more than we could produce. The beach traffic patterns created by DUKWS achieved industrial precision that stunned Japanese observers. Vehicles followed predetermined routes. Loading zones were organized. Traffic flowed continuously. The chaos Japanese planners expected never materialized. Instead, beaches functioned like factory floors, materials arriving, being processed and distributed with mechanical efficiency. Commander Ichiro Sasaki, observing from concealed positions on Iwo Jima, documented traffic patterns before being killed. The beach is a factory. Materials arrive, are processed and distributed with mechanical precision. Each vehicle follows predetermined routes. There is no confusion, no wasted motion. They have made invasion an industrial process. Medical configuration of DUKWs saved thousands of American lives while demonstrating to Japanese forces the value America placed on individual soldiers. Each medical DUKW could carry 12 stretcher cases or 25 ambulatory wounded. They were equipped with plasma, morphine and surgical supplies. Medics could begin treatment during evacuation. The speed of evacuation, often less than 30 minutes from wounding to surgery, achieved survival rates seeming miraculous to Japanese medical officers. Dr. Koji Yamamoto, forced to treat American wounded on Guam, documented the evacuation system. Their amphibious ambulances are emergency rooms that swim. Wounded who would die in our army survive in theirs. They fight to preserve life while we fight to expend it. Supply of fresh water via DUKW demonstrated American solution to one of amphibious warfare's greatest challenges. Pacific islands often lacked fresh water, forcing attacking forces to depend on shipped supplies. DUKWs equipped with water tanks could deliver 500 gallons per trip. Some were modified with distillation equipment, converting seawater to fresh during transit. This self-sufficiency in water supply enabled sustained operations on islands where Japanese defenders expected American forces to weaken from dehydration. Colonel Matsuo Yamada, defending Peleliu's water-scarce terrain, had based his defense on American water shortage. His final report contained bitter recognition of miscalculation. We defended water sources they didn't need. Their trucks brought unlimited water from the ocean itself. We thirsted while they bathed. Refrigeration units installed in some DUKWs brought fresh food to frontline troops, a luxury stunning Japanese forces subsisting on rice and dried fish. These vehicles could transport frozen meat, fresh vegetables and ice cream from supply ships to combat units. The psychological impact of American troops eating fresh food while Japanese forces starved created morale collapse more effective than any propaganda. Corporal Yasuo Tanaka, captured on Iwo Jima, described watching Americans unload refrigerated DUKW's ice cream. They brought ice cream to a battlefield. We hadn't seen rice in a week, and they were eating desserts. How do you fight an enemy that brings ice cream to combat? Workshop DUKWs, equipped with machine tools, welding equipment and spare parts, brought industrial capability to the battlefield. These mobile workshops could manufacture parts, repair weapons and modify equipment at front lines. The ability to produce rather than merely consume supplies represented a revolution in military logistics Japanese forces had never contemplated. Technical Sergeant Hiroaki Sato, an ordnance specialist, observed workshop DUKWs operating on Okinawa from his hidden position. They brought factories to the battlefield. Broken weapons were repaired on the beach. Damaged vehicles were rebuilt where they stopped. They didn't supply their army. They recreated it continuously. Command and control DUKWs, equipped with multiple radios, maps and communication equipment, served as mobile headquarters that could operate on land or water. This flexibility allowed American commanders positioning themselves wherever battle required, maintaining control while moving with the action. The contrast with static Japanese command posts, vulnerable to bombardment and isolation, was stark. General Mitsuru Ushijima, commanding the 32nd Army on Okinawa, noted American command flexibility in his final report. Their generals command from swimming trucks, appearing wherever battle is critical. Our generals command from bunkers, fixed and targetable. They have mobilized command itself. Landing of construction equipment via DUKW enabled immediate improvement of invasion beaches. Within hours of initial landings, bulldozers and graders delivered by DUKW were creating roads, clearing obstacles and improving beach exits. The speed of infrastructure development turned contested beaches into secure logistics bases while fighting continued inland. This immediate construction capability multiplied the effect of all other logistics efforts. Major Kenji Ito, engineering officer for the 14th Division on Guam, watched American beach development from concealment. In one day they built roads we couldn't construct in a month. Their amphibious trucks brought not just supplies, but the means to improve supply. Each hour their positions strengthened while ours weakened. Signal intelligence units operating from DUKWs, equipped with radio intercept equipment, could monitor Japanese communications while maintaining mobility. These vehicles would position themselves optimally for reception, then relocate when threatened. The combination of mobility and electronic warfare capability allowed real-time intelligence gathering that fixed Japanese command posts couldn't achieve. Lieutenant Yoshio Kobayashi, communications officer on Saipan, realized American intercept capabilities when his encrypted messages triggered immediate American responses. They listen from trucks that swim. When we relocate, they follow. When we broadcast, they triangulate. Our communications betray us to an enemy that moves like water. Photographic reconnaissance, DUKWS, equipped with aerial cameras and dark rooms, could process intelligence photographs while returning from missions. This immediate analysis allowed American forces adjusting tactics based on current intelligence rather than waiting for rear area processing. The speed of the intelligence cycle, from collection to analysis to action, compressed decision time beyond Japanese ability to respond. Captain Saburo Hayashi, intelligence officer for the 31st Army, captured Japanese frustration. Their reconnaissance develops while traveling. Photos taken at dawn guide attacks at noon. We analyze yesterday while they act on today. The cultural impact of DUKWS extended beyond military defeat to challenge Japanese assumptions about American society. Vehicles were operated by farmers from Iowa, mechanics from Detroit, teenagers from California. Not elite warriors, but citizen soldiers who brought civilian skills to military problems. This democratization of warfare contradicted Japanese beliefs about military specialization and social hierarchy. The vehicles themselves embodied American values: practical, efficient, adaptable, and produced in overwhelming quantity. Colonel Masahiko Takeshita, a military philosopher and instructor at the Army War College, wrote from captivity about cultural implications. The amphibious truck is American society made mechanical, classless, practical, and infinitely reproducible. We sent warriors to fight citizens, and the citizens won because they transformed war into work. By July 1945, DUKWs had delivered over 5 million tons of supplies across Pacific beaches. They had evacuated 150,000 wounded. They had transformed amphibious assault from specialized military operation into logistics exercise. The Japanese Navy, which had spent decades perfecting amphibious doctrine, watched its expertise become irrelevant. The Imperial Army, which had fortified islands to exploit amphibious vulnerability, saw those fortifications bypassed by vehicles making vulnerability meaningless. Vice Admiral Takejiro Onishi, creator of the Kamikaze Corps, wrote in his final letter before suicide, "We prepared to fight the last war more perfectly. They created a new war we couldn't imagine. The amphibious trucks were not weapons, but proof that the age of warrior spirit had ended. The age of industrial warfare had begun, and in that age Japan was already extinct." The last Japanese commander facing DUKWs in combat was General Tomoyuki Yamashita in the Philippines. By 1945, he had received detailed reports about their capabilities and impact. His chief of staff, Lieutenant General Akira Muto, had compiled analyses of American amphibious operations showing DUKW logistics' decisive impact. In his final operational order, Yamashita included a telling admission. Enemy amphibious vehicles make traditional defense impossible. They transform sea into land at will. We can delay but not prevent their logistics superiority. Fight with honor knowing the outcome is determined. Post-war interrogation of Japanese officers revealed the depth of impression DUKWS had made. Admiral Soimu Toyoda stated, "The American amphibious truck was worth more than aircraft carriers. It made every beach a port, every shore a highway." General Yoshijiro Umezu, Chief of Army General Staff, testified, "We couldn't compete with a nation that could conceive and build such vehicles while fighting globally." Colonel Takushiro Hattori, Operations Chief at Imperial General Headquarters, summarized the consensus. The DUKW wasn't just a vehicle. It was evidence of a civilization we couldn't match. Statistics of DUKW production and deployment told the final story. General Motors produced one DUKW every 15 minutes at peak production. By war's end, they had built more DUKWs than Japan had produced military trucks of all types since 1937. Each DUKW represented 18,000 parts sourced from 300 suppliers across 30 states, assembled by workers who had never built military equipment before the war. The supply chain supporting them stretched 10,000 miles from Detroit to Okinawa, functioning with precision peacetime commerce rarely achieved. In final analysis, Japanese commanders hadn't simply failed to imagine amphibious trucks. They had failed to imagine the industrial democracy that could produce them. DUKWs weren't surprise weapons, but inevitable products of a society that valued practical solutions over elaborate doctrine, that trusted 18-year-old farmers to operate complex equipment, that could mobilize civilian industry without losing civilian efficiency. Every DUKW climbing from ocean to beach carried with it the entire weight of American industrial civilization. Colonel Hiramichi Yahara, the last senior Japanese officer observing DUKWs in combat, watched them operating off Okinawa days before Japan's surrender. In his post-war memoir, he wrote the epitaph for Japanese amphibious defense doctrine. "We built walls between land and sea. They built vehicles, making the walls meaningless. We studied how to stop landings. They studied how to make landings irrelevant. We perfected defense against the last war. They invented the next war. The amphibious trucks didn't defeat us. They simply drove through our defeat as though it were another kind of terrain to be crossed." The last DUKW operations in World War II occurred during the occupation of Japan itself. Vehicles that had breached Japanese island defenses now delivered humanitarian supplies to defeated Japanese cities. Japanese civilians watched the same amphibious trucks that had supplied the invasion of their defensive perimeter now bringing food to their starving population. The vehicles hadn't changed, only their cargo. They remained what they had always been, tools of an industrial power that could transform any problem into a logistics exercise and solve it through mass production. Lieutenant General Torashiro Kawabe, Deputy Chief of Army General Staff, witnessed DUKWs operating in Tokyo Bay during occupation. His observation, recorded in his diary, captured the final Japanese understanding of what they had faced. The American amphibious trucks continue their work from war to peace without modification. They are not weapons of war, but instruments of capability. We fought against capability itself, the ability to transform imagination into metal, to produce solutions faster than problems could be created. Each truck driving from sea to land demonstrates why we lost. We had warriors, they had engineers. In modern war, the engineers always win.